series in control systems. So today we are going to start with unit 3, which is frequency response analysis. So already we have completed 2 units, like the first one will be modeling and determining the transfer function of rotational systems and translational systems, whereas the second unit we dealt with time response analysis and different parameters like rise time, peak time and underdamped conditions were discussed. And now we are going to discuss about unit 3, which is frequency response analysis. And let us start with an introduction. So why frequency response matters? So the main thing is real world problem, which is inability to predict the system behavior at different frequencies. And this, if frequency is not the constant, then it affects industries in the major areas like power systems, communication industries and motor control. So the frequency is very important in communication. So what is the impact if we are not going to consider this frequency as a main parameter? So the instability happens, the performance will be very poor, and so that the equipment damage happens. And what are all the limitations of time domain analysis? So time domain analysis, we had a little bit of limitations like difficulty in predicting the steady state behavior and complex for higher order systems. So when we go with the simpler transfer functions, the analysis will be very simple. Whereas when we go with the higher order systems, then the system becomes complex. So there is no direct frequency inside. So these are all the time domain limitations. And what is the technology gap between the time domain and the frequency domain? So there is no direct relationship between the time and the frequency, and limited predictive capabilities and design challenges for complex systems. So here we have a difference between the time and the frequency domain analysis, whereas it is limited to transient and it predicts the steady state behavior. And this is complex for higher order systems, that simplifies the higher order systems. And in time domain, there is no frequency, but there is direct frequency inside. So this is a steady state behavior is unclear, whereas clear system characterization is done using frequency domain analysis. And coming to the definition, like steady state response to sinusoidal input, this is what we call it as frequency response. So in the right side picture, we clearly show the frequency response for a particular time period. This is a relationship between time and the amplitude. So coming to the mathematical relations, we learnt about the R of t, and here the input will be the R of t and the output will be sine omega t, which is the sinusoidal waveform. So when we substitute S is equal to j omega, the representation which is t of j omega. So the magnitude and phase angle is differentiated. So magnitude is magnitude of t of j omega into r of j omega, whereas phase angle, which is t of j omega plus r of j omega. So transfer function, it transforms to sinusoidal transfer function. So here we have a frequency domain block diagram with time domain of 1 second and for a particular period of time, how frequency changes. So what are all the key domain specifications is resonant peak, resonant frequency and bandwidth. This plays a major role. So resonant peak is maximum value of magnitude response, whereas resonance frequency, which is mentioned as omega r, this is frequency at peak amplitude. And the bandwidth, it ranges from 70.7% magnitude response. So here we have a typical gain phase characteristics of a control system, which indicates the resonant peak, resonant frequency and bandwidth of the system. So the decrease when the waveform gets a peak and it again comes to the nearing zero value, that is what we call it as cutoff rate. And coming to the practical applications, mainly it deals with the power systems like frequency stability analysis in power grids, and in communication, filter design and signal processing, and in motor control, speed and position control systems. So all these plays a major practical applications in the system. So let us summarize what we discussed in this video is about introduction to frequency response analysis, in which we learnt about the comparison between the time domain and the frequency domain and advantages. So compared to time domain limitations, there are many advantages in frequency domain. And coming to the mathematical representation, input was represented by R of t and output was represented by C of t, and it gives an output of sinusoidal waveform with a magnitude and the phase angle. And the key specifications is resonant peak, magnitude value, and resonant frequency and bandwidth plays a major role along with the cutoff rate. And in the practical applications, we discussed about the power systems and communication applications. So let us meet in the next video. Thank you.